Lesson 10.2 notes on powers of products property. We'll start our key ideas. There are 3 different properties that we'll be looking at today. The product of powers property, meaning that you're going to multiply powers together. If you're going to multiply powers with the same base, then you can add their exponents. So 4 to the second power times 4 to the third power equals 4 to the 2 plus 3 power gives you 4 to the fifth power. Right? And you can look at that. You can expand it out. You can look at 4 times 4. And then if you multiply 4 times 4 times 4, so here's 4 to the second and 4 to the third, then you can see when you get that all expanded out that that is 4 to the fifth. Algebraically, if you have a to the m power and you multiply that by a to the n power, then we would have a to the m plus n power. The power of a power property, similarly, if you have a power, 4 to the 6th, and you are raising it to a power, to the third power, you find that by multiplying the exponents. So if you get confused and you can't remember, stretch it out and look at it. This one's going to be really long. So we're going to do 4 to the 6th. 1, 2, 3, 4, 5, 6. There's 4 to the 6th. And then you would multiply that by 4 to the 6th. 1, 2, 3, 4, 5, 6. There it is 2 times. 1, 2, 3, 4, 5, 6. So there's 4 to the 6th 3 times, 4 to the 6th to the third power. And if I count those all up, I've got 4 to the 18th power. Isn't it nice to be able to write 4 to the 18th power instead of having to write it all out like that? Written algebraically, you can't multiply those together. I guess you could. You could write a to the m(n) power, a to the m times n. Okay. And then the product of a product, so you are to find, I think I typed the wrong thing there. To find the power of a product, you have to find the power of each factor and multiply. Right? So we're going to take 3 to the 5th and then multiply that by 2 to the 5th. If I spread this out, you can see it's 3 times 2 times 3 times 2 times 3 times 2. 1, 2, 3, 4, 5. And then I can use the commutative property to switch everything around so that I can regroup and put all of the 3's together. So I've got 1, 2, 3, 4, 5 3's. And I also have 5 2's. And then if you have numbers here, you go ahead and evaluate that. So you go ahead and find an answer. Right? Algebraically, I would take a to the m power times b to the m power. Right? So let's look at those applied in examples. Multiplying powers with the same base. Stretch that out and go 1, 2, 3, 4, 2 to the 4th times 1, 2, 3, 4, 5, 2 to the 5th. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 equals 2 to the 9th. I can just add 4 plus 5. All right. Negative 5, we don't write it if it's to the first power, but this is the same as negative 5 to the first power times negative 5 to the 6th power. So that's the same as negative 5 to the 1 plus 6 power, or 7th power. All right. And then for a variable, works the same way. I still have the base of x. So I can have x to the 3 plus 7 power is x to the 10th. All right. You have 3 u tries. There's nothing tricky in there. Now, I am going to go back here. This is, I've got a typo in my notes, so we need to change. This should say the power of a product. So let's change that. Hopefully by the time you get your notes printed out, I will have changed it and you'll have the correct copy on Google Classroom. Okay, so finding a power of a power. We do that by, let's do one long example. So I've got 3 to the 4th, and I'm going to do that 3 times. So I've got 1, there's 3 to the 4th power once. There's 3 to the 4th to the 2nd power. And there's 3 to the 4th power to the 3rd power. So I've got 3 to the 4th power, and I've got 3 of them. And if I count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 times 3 is 12. Let's write it out long. So right? And you don't have to stretch it out every time. Works the same with a variable. W to the 5 times 4 is 20th power. Okay? That's okay. That's okay. Number 6 is going to be a little bit tricky. To be sure that you work from the inside out. Actually, you should be okay. I think the only thing that looks tricky is that you've got an extra set of parentheses because the negative 4 is raised to the 3rd, but you're going to do it exactly the same way. It's just going to be negative 4 and then multiply your exponents. All right, and example 3, the power of a product. So you have a product inside the parentheses, and it's kind of like you're distributing. You're distributing this power to everything inside the parentheses. All right, so we're going to say that's the same as 2 to the 3rd and x to the 3rd. And then you need to go ahead and evaluate 2 to the 3rd. Instead of leaving a number as an exponent or as a power, you're going to simplify it. 2 to the 3rd power is 8. So you're going to make that 8x cubed. And then we're going to distribute the power or the exponent to everything in the parentheses. So we've got 3 to the 2nd power times x to the 2nd power times y to the 2nd power. And we can simplify 3 to the 2nd power as 9, 9x squared, y squared. And nothing tricky there. There's a decimal, but nothing tricky about it. Okay, and then the last example, simplifying an expression. So I've got a word problem where we're showing some details about computer storage. And it starts by telling you that a gigabyte of computer storage is 2 to the 30th power bytes. The details of a computer are shown. How many bytes of total storage does the computer have? Right? So we start by talking about the computer has 64 gigabytes of total storage. You can see that there. Notice that you can write 64 as a power. That's 2 to the 6th power. So we're going to use a model to solve the problem. I'm going to write that as an equation. So the total number of bytes, which is what we're trying to find out, equals the number of bytes in a gigabyte. That is 2 to to the 30th power times the number of gigabytes that we have, which is 2 to the 6th power. And so if we want to multiply 2 to the 30th times 2 to the 6th, you could imagine stretching 32s and 6 more, and we would end up having 2 to the 30 plus 6, or 2 to the 36th power. And then the U-try, they ask you to do basically the same thing, just to look at the 16 gigabytes of free space, and you'll want to write 16 as a power of 2. All right.